So the next part of the algorithm is we're going to create a function called Encode Units. And it basically just will turn, when this function is called, it will turn something into a bunch of ones and zeros. 0 for false and 1 for true. So whatever x is, it could be data, for example. If we ran lowercase data through this function, anything that was negative or 0 would be returned as a 0 in data. And then anything that was bigger than 1 or equal to 1 would be returned as 1. So we don't really want to run data through it, right? We're not going to run data through this. We're going to eventually use this encode units to change some frequencies into true or false. Was the item in this particular invoice, right? And this has no output. This is a program that we're going to call up to convert counts to yes and no's, or zeros and ones, to booleans. Okay. All right, so the first part of our algorithm is we're going to create a pivot table, and I'm going to leave this input box, and I'm going to go to the next input box, and I'm going to create an object named basket. And all basket is a massive pivot table. And what it's going to do is it's going to, right here, this right here, if this is true, because this is a Boolean statement, 2 equals means a Boolean statement. So if in the country column of the data table, if that equals Australia, then this shaded thing will be equal to true. If it's not equal to Australia, it'll be equal to false. And what that does is it filters data to include only those transactions that occurred in Australia. And I'll give you an example of how that particular works. So we have a table here, right? We have a bunch of countries in this table, and we're going to just select Australia. Okay, so now the only countries in this table are, the only transactions are the ones that happened in Australia. So that's what this does right here. So Pandas has got some really cool features. The rows in the data table will only be returned if this is true. So this does exactly what we did in Excel. It filters everything out but Australia. Okay? And then we're going to group by. So this is an extension of the first line. So we're going to group that shrunk down data set. We're going to group it. We're going to shrunk down to Australia. We're going to group it by invoice number and description. Okay. We're going to create a massive table. For every invoice number below that is going to be a description. And then we'll go to the next invoice number and we'll list all those descriptions. So it's going to be a massively long table, right? A huge long table. It's not a pivot table yet, right? And then this is going to be the column that we sum on, right? We're going to sum on the quantities. Now we're not interested in the quantity sums here. That's not what we're interested in. What we're interested in is, was this product in an invoice? Yes or no? So what we're going to do is we're going to sum on quantity, and then eventually we're going to change that sum of quantity into a 1 or a 0. 0 meaning false, 1 meaning true. And then we're going to unstack, right? We're going to unstack. And invoice number will be the pivot table rows, and description will be the pivot table columns. The description will be the pivot table columns. And anything that is empty, any cells that are empty, will be filling in with 0. Okay, so this is what basket is going to be. It's going to be a massive pivot table. Okay, since invoice number was first, invoice number right here is the row index of this massive pivot table. And because description was second, descriptions are the columns of this massive pivot table. And this pivot table has 56 rows and 607 columns. Okay? And most of these sums of quantities are 0. Okay, so in this particular invoice, the customer bought 240 12 pencil tall tube posse, right? Whatever that is. In this invoice, this customer bought 384 12 pencil small tube woodland. What else did this person or this company buy in that particular row or in that particular invoice? I wonder if we can move to the right here. Oh, we can't do that, can we? Okay, so most of the time we have 0, right? We have 0. Let's look at the final few transaction numbers. Okay, so we got zeros in the final rows. What things are bought together? And we have a yada, yada, yada here because it's just too wide. So we're just not going to see enough, right? We're not going to see any. We're not seeing, because we have 607 columns here. Now we could export this to Excel if we wanted to. So let's go ahead and do that. So we need this code here, and we'll go down to here, and we'll go ahead and output it. So the object, the the pandas data frame is called basket. So I'm going to replace the data name. This is our original data frame, our pandas data frame. We're going to replace data with our new data frame basket. And then we'll change it from data.csv to basket.csv so we can view it in Excel. Okay, it's not outputting basket anymore because if you want to see basket, if there's a line of code that follows it, you have to put a print statement here. Okay, so let's go up here to home and then open up basket. And then we'll download it to see what it looks like. And we'll look at one transaction. And we'll see what kinds of things are in that one transaction. So each one of these right here is a transaction. So looking at the word sum right here, we can find out what things were purchased in this. So we have this alarm clock here and that alarm clock there were purchased together. And then we have this black, blue, whatever that is, purchased. And we have this blue dine something. So we got several products in this first transaction, right? Is that it? So it's a pretty wide table, right? So there's 107 items purchased in that first transaction. 107 items purchased. Okay. Ooh. Okay. So that's how that works, right? Okay, so the next bit of code is we're going to apply that function that we created called Encode Units. Okay, and then I'll output it right here. Whoops. basket sets. So you can think of this basket as the quantity basket, and you can think of this as the basket of sets, right? What things are bought as sets by our customers. So we're gonna apply our function that we created above to our quantity pivot table that we just created up here, right? And remember what this does. It replaces anything that's 0 or less with zeros and anything 1 or more with ones, right? So let's go ahead and run this. And it will output the pandas data frame basket sets because we have this at the end of the code. And now notice that everything that was 0, 0.0 is 0, and everything that was greater than 1 or greater is now coded as a 1, right? So if I save basket sets to basket underscore sets dot CSV, I can now look at, there it is right there. I'll go ahead and download it. We can now calculate visually what's going on. Okay, so here's basket sets, and here's our first transaction, right? So how many things were purchased? 14 things were purchased. We're summing the zeros and ones. So 14 different products. 14 different products were purchased together in this one transaction. In the second transaction, 8 things were purchased together in different quantities, but 8 different products were purchased in this particular invoice, right? And then our third transaction, 9 unique products that we sell were purchased, right? And again, this is Australia, right? These are our Australian customers, okay? Okay, so I'm going to go ahead and get rid of that. And I don't need this anymore. And so we have basket sets. So our next set of code is our association rules. We're gonna output our frequent item set. We're gonna calculate our popularity list. Okay, this is our frequent item sets, right? We're only going to output those that have a minimum support of 0.07. Okay, and so we're going to go ahead and run that. We probably should copy this and put it at the end of our line here. Put it at the end of our code so it'll output it. So let's go ahead and run it. Control Enter. Okay, so our most popular item is 36 pencils tube red retro spot. That's our most popular item. Well, I guess maybe not. Let's do a sort. Okay, so what I did here is I added this code on to this output. So the cool thing about a pandas data frame is you can sort it by something, right? So we're going to support it. We're going to sort it by the column support, and we're going to do descending. So the default is ascending. So we're doing ascending, which equals false. We're going to do descending. So let's go ahead and hit enter. So our most popular item is red toadstool LED nightlight. That's our most popular item. And notice that our last item down here has a support of 0.071429, right? So if I lower this to 0.06, our list will grow longer, won't it? Well, I guess I guess there's no other. I think these are the lowest frequencies, right? So there's no other products below that. So if I set this at 0.08, these won't show. So we'll have even fewer items in the list. Okay, so then it's cutting it off at 0.08. See that? So if we have a minimum support of 0.08, then it cuts off, and there's no products with a support of between 0.089 and 0.08, right? So we'll go ahead and set that back at 7. So this is really not doing anything with this minimum support. It's really not doing anything because we only have 189 products in our list anyway, right? But our most popular is this one, and our least popular item is the homemade jam, scented candles, right? Whatever that is, the rest of it, right? Roses, Regency, tea, something, right? That's our least, well, it's tied. These are all tied for least popular. They have the same support. Okay? And you can think of this as the probability that these product items show up on, at least one in quantity shows up on an invoice. Okay? So we'll go ahead and delete that. That's just outputting it in an order. And then we'll bring in our association rules. Okay. We're going to bring in the association rules. This is where we're doing the actual association mining. Okay, so we're going to we pull in this function called association rules. We're looking at frequent items, right? Frequent items sets. Our metric is lift. Our minimum threshold is 1. And we're going to sort the result by lift from biggest to smallest lift. All right, so let's go ahead and then I'll type ASSOC. OC. And that'll output the pandas data frame. Okay, so what we have here are products. We have an antecedent product, red retro spot cake stand, and our consequent product, our 36 pencil tube red retro spot. This product has a support of 0.071429. The consequent has a support of the same 0.071429. Their joint support is 0.071429. The confidence is 1 and the lift is 14. Now, you can think of the support as the joint probability. The probability of A and C. That's what the support is, right? The confidence you can think of as the probability of C given A. That's what you can think of the confidence as. It's a conditional probability. So if A is in the transaction, what's the probability that C is in that transaction? Okay. Another way to think about it is you're dividing this by the antecedent. Okay, so this is the probability of A and C, and this is the probability of A. Now, when you get the lift, what you're doing is you're taking this divided by that to get the conditional probability confidence, and then you're also dividing by that. That gives you the lift. Now, the way the lift works is if the lift is bigger than 1, then you can think of that as these two products are bought in pairs. You can think of these two products as complements, like ketchup and mustard, or hot dog buns and hot dogs, or cars and tires, right? If the lift is 1, then these two things are independent. They're purchased independently. Consumers just buy them. There's no dependency there. If the lift is less than 1, you can think of them as substitutes. Instead of buying this, we buy that. If we choose to buy this, we won't buy that. That's if the lift is less than 1. So that's how that works. So it's kind of a way you can calculate correlations, if you will, with text, right? The higher the lift, the more likely you are to purchase them together than by themselves. Okay? So, for example, if the lift of a burger and ketchup is 3.33, right, instead of 14. So if it's 3.33, you could say the likelihood of buying both is 3.3 times more than the likelihood of just buying the ketchup by itself. So that's how you can think of the lift, right? Okay, moving on. Okay, now we're going to kind of like deploy this. So you can think of this as kind of how we would deploy it, right? So I is an input, right? When I is 2, we're getting the second country in our list of countries, right? And that, well, it's actually the third country, right? Because our first country is 0, and then we're setting I equal to 2, so we're going to be doing Australia. Okay, so this is kind of like how you can think of us deploying this model. So if I run this, I'll get the same exact output. I'm going to print the nation, right? I'm going to define the basket sets. And notice we're applying that Encode Units, one-hot coding. We're turning the counts, the sums of quantity. We're turning them to 1s and 0s right here. So that's in one step. We have our frequent item sets. And then we have our association algorithm, right? That calculates lift, confidence, and etc., right? Except here we're sorting it by confidence, but down here we're going to sort it by lift. You can sort it however you want, right? So let's go ahead and hit enter here, or control enter, and we can see it's this exact same output. Now if we change this to 1, notice our output here was Australia's associations, product associations. If we change it to 1, we get France's, right? In France, the maximum lift for France is the combination alarm clock bake like green and alarm clock bake like red. That has a lift of 8.44523. The second highest combination of products is alarm clock bake like red and alarm clock bake like green. So these are bought together and these are bought together. They have the 2 highest lifts, right? So maybe our French customers like to buy alarm clocks. One for, maybe they love alarm clocks. I'm not sure why it is. So the top product for them, pair of products, is alarm clocks. The second highest is alarm clocks. Third highest is alarm clock. The fourth highest is alarm clock. So that's kind of interesting, right? And then red spotty paper plates and red retro spot paper napkins have a lift of 7.4685, which makes sense, right? When you buy paper plates, you are buying paper napkins. Okay, so that's how it would be for France. Okay, and then we can scatter plot. Let's go back to Australia here. Control Shift Enter. And then we can scatter plot support versus confidence, support versus lift, or confidence versus lift. So I hit Control Shift to run the code, and you can see that we have support versus confidence here. And there aren't a few dots here. It looks like there's just a few of them, but you got to remember we set the transparency of the scatter plot to 0.4. And you can see right here that there's probably maybe 1 point here, but there might be 100 points here. There might be 20 points here. All right, so there's a pile up at each one of these points, right? But there isn't a pile up here. Maybe there's just 1 or 2 here, right? In figure 2, we have support versus lift. And now you can see there's more dispersion, right? So our support here is about 0.07 or 7%, or it's about just under 9%, or it's about 10.6%. So our support doesn't change here or here. The difference between that graph and this graph is we're going from confidence here to lift here. And so when we go from confidence to lift, we get a little more dispersion vertically, right? We get a little more dispersion vertically. Now down here is what we have. We have confidence versus lift, right? And you can see that we have a positive relationship between confidence and lift, which makes sense, right? It makes sense. And the reason why it makes sense is because remember what confidence is. Confidence is the probability of product C given product A. And A is the antecedent and C is the consequent, right? Now that can be rewritten as the support of A and C, right? Or the probability of A and C being the same transaction, divided by the probability of the antecedent or the support for product A, right? So that's the confidence. The lift is the same as confidence, but we're dividing confidence by the probability of the consequent, the support for the consequent. So what we end up getting here is the same thing, but we're adding this probability here. Probability of the consequent. So if confidence goes up, then this goes up, right? So if we hold the probability of the consequent or support for the consequent constant, if we hold that constant and this goes up, then this will go up, right? So it makes sense that there's a positive relationship between confidence and lift. Okay. All right, so the next thing we want to do is create a bit of a script here. So kind of as part of the deploying of our model here, we're going to create a bit of a script so we can better understand our output. Okay. So product A, I'll go ahead and print product A here for you. Okay. And then I'm gonna hashtag out this part down here. Okay, all I'm gonna print is product A. Okay. It's in this thing I called list, or sorry, it's in this thing I called assoc. This is an object, right? And then LOC, this is how you pull out a cell, a row, or a column. I stands for index, right? So when you're using ILOC, you want to put in numbers. So this is going to get item 00 out of this object. So let's go up and see what that looks like. So up here, here's our association, right? We sorted it by ascending, but the problem is here we have to redefine it. So we're going to redefine it as this sorted version of it, right? Okay, we're going to sort it by lift here, right? We could have also just, well, we could do this instead. Let's just get rid of that. And then just change this to lift, right? So we're going to sort this object ASSOC, assoc. We're going to sort it by lift, right? Oh, sorry. I got to type ASSOC for it to print out. Okay, so this is the 0 row. This 0 here, just coincident, I think, right? This is the 0 column, and this is 0 row. This is the 1 column, and this is the 1 row. So this right here is in the 0, 0 position, right? Okay, so that's what that product A should be red retro spot cake stand. We're in the 0, 0 position right here, right? Now I'm going to put a hashtag in front of that 0 right there. Okay, so if I am pulling this out, if I'm pulling that product name out of this object, it's in a list form, right? So one way to get rid of that list form is to, I want to pull this out of the list, right? So I can put a bracket 0 there and it'll pull it out. See that? I wonder if I could do this. I wonder what happens if I do this here. Oh, yeah, so yeah, this is kind of junk. We don't want this in output. So that's why I had list there. So if I type list, I'll convert this to a list with one thing in it, right? And in order to get that one thing out of that list, I have to put a bracket 0 bracket. And so I get the name of the product, right? And then this NA here, I'm going to print the NA. Okay. And what this does is it looks at our object basket, right? And then will filter by red retro spot cake stand because that's what product A is, right? So this is going to sum the quantities in our object basket. And it's only going to sum across red retro spot cake stand, right? So if I print NA, I'll get the numbers of the quantity, the total quantity of red retro spot cake stands that were sold in all the invoices that are in the data set, right? And then product C here is the consequent product, right? It's in the 0 row and column 1. So let's go back up here. So it's in the 0 row, column 1. So the output of this should be 36 pencils, tube red retro spot. Again, if I don't do list, and I don't do this bracket 0 here, whoop, sorry, I gotta change that to B. It's gonna give me some junk I gotta get rid of, right? Oh, product C. I gotta get rid of this junk here, right? I gotta get rid of this junk there and there. So the first part to get rid of the junk is typing list to convert this into a very simple list with one thing in it. And then I got to get it out of the list, right? There's only one thing in this list, and it's in the 0 spot, right? So that's how you pull that out. And then I want to count. I want to sum up the quantities of this product, which is locally defined as product C, from the basket pivot table, right? So I want to sum that. So I'll go ahead and print that right here. Change that to C. So 385, this product was sold, a total of 385 of this product was sold in all those invoices. And only 73 of these were sold in all those invoices. Okay. So let's go ahead and print our script here. Okay, go ahead and enter here. So this right here, assoc.shape bracket 0 gives us the number of rows, right? That gives us a number of rows, 800. So if we go back up here, we'll see that there are 800 rows in this association table, right? So that's what that is. By the way, the shape, if you remember what the shape is, I'll put it here to print it. The shape is the number of rows and the number of columns, right? So 800 rows and 900 columns in the object I named ASSOC, right? So that's what this is. This is the shape. 800 rows and 9 columns, right? And we just want to know the number of associations there. So I'll get rid of that line of code. I'll get rid of this to clean up our script here, our output. Okay. Customers purchased 73 of these, right, of that product, and 385 of this product. And then down here, we're talking about the lift, right? The lift underscore A underscore C is in the assoc object in row 0, column 6. Remember, that's not the 6th column, it's the 7th column, because the first column is 0, right? So if you come up here to the row 0, right, this is column 0, column 1, column 2, column 3, column 4, column 5, and then column 6. So the lift of these two products is 14. So down here, let's see if I can wind this up to make it look better. There we go. Since the lift of this product and this product equals 14, what that means is the likelihood of buying both, maybe I should get rid of that A there, rerun it. The likelihood of buying both is 14 times more than the likelihood of just buying just the red retro spot cake stand product by itself. So in other words, these products are generally bought together. So in economics, we'd call them complements, right? If their lift was under 1, then we would call them substitutes, right? You'd buy one instead of the other, or vice versa. Okay, that's it for the algorithm that you can use in Python to do association mining.